So I'm Maxime, and with Jens today, we'll talk about the past year, what happened in the Vhost and Virtio world last year, and what is coming next. So we will start with some community updates, then we jump to past year achievements, and we finish with work that is being done today or that we plan to do in the future. So last year, in the past year, there were some big changes in the maintainers. So Yuanan and John Feng decided to resign from their role of Vhost and Virtio maintainers. So I would like to thank them for all the work they did, both in terms of code and in terms of reviews. And I'm happy that Tiwei, who is not here today, and Xiong accepted to join me, to help me as maintainers. So welcome to them. I collected some statistics that covers from 1708 to 1808. So the past year we did about 300 patches for more than 40 contributors. The main company that contributes today in new features are Intel, Red Hat, and also Sixwind contributed in the offloading in Virtio. So what we have done last year? So one of the first features is IOMMU support in Vhost user backend. It was introduced in 1711. The idea is to be able to enable the virtual IOMMU in the guest when we use the Vhost user backend. We do so in order to protect the guest kernel from an application running DPDK that could be either malicious or buggy. For example, without the IOMMU, an application could pass any random guest physical addresses as a descriptor buffer address. And on backend side, if we are in receive mode, it would result in some kernel memory, for example, or another application memory to be leaked or to be overwritten in case of a transmit. So to do this, and for performance reasons, the Vhost user backend implements an IoTLB cache so that we don't have to query QEMU for each time we need to translate an address to do the translation. So this IoTLB cache, when we have a static mapping in the guest, which means that we run DPDK with a Virtio PMD, in this case, the overhead is really not significant. When you have 1 gig pages, we can see that some measurement, this is a PVP benchmarks, and the measurements show that we don't have a big overhead. With 2 meg pages, we have more and more entries into the IoTLB cache, so we start to see a performance degradation. What we could do in the future to improve this could be to merge the IoTLB entries that are contiguous both in the guest physical address space and in the host virtual address space. For when we use the Virtio kernel driver, this is another story. In this case, the overhead is really significant because we have a dynamic mapping. Each time a buffer packet is processed, its buffer gets unmapped. And so on the host user side, it results in receiving an IoTLB invalidate. And so the next time we try to access the same buffer or any other buffer, we get an IoTLB miss. And so we need so it adds a big overhead. So there is not much we can do to avoid this. And since there are no real security gain to use the VIOMMU when we use a kernel driver, because it would mean protecting the guest kernel against itself. Maybe it is not needed to invest much time to improve this. Anyway, we need to have it working. And what we see today is that, especially with dynamic mapping, we see some packet drops. So that's one thing that we will need to do to improve the situation, is to make the IoTLB miss request blocking in the enqueue path so that we don't drop the packets. Also, SPDK team is using the Vhost user library, and they talk about adding an API so that they also can use the IOMMU APIs in the Vhost user library. And today, this is only usable inside the Vhost user library. So that's another improvement we could do. This year, in 1805, Fan Zheng from Intel added the Vhost crypto backend. So it basically implements the Virtio crypto specification. And the idea is to translate the Virtio crypto requests into DPDK crypto operations. So for now, from what I understood, it only supports HashMac, SHA-1, and AES CBC 128 ciphers. So it planned to add sessionless mode, from what I understood. Another thing that happened last year, early this year, sorry, was that we have been made aware of a security issue in the Vhost user library. So we have a CVE for it. So the problem was that a malicious guest could make the Vhost user backend to crash. So, for example, could make OVS DPDK to crash, or which is more likely, or it could also corrupt some memory or leak some memory if in some unlikely conditions. So the problem was that the guest could connect the Vhost user backend to access memory that were out of the memory regions of the guest, creating a seg fault. And because the library did not check the entire range of the buffer that was passed by the guest. So we fixed it by ensuring that all the buffer passed by the guest are fitting into the memory regions, and that they are also contiguous in the host virtual address space. So Intel test people reported that there is a light performance regression in some cases. So we had more checks, we have some loops that we introduced. That's still an open issue. We need to look at it. But overall, the performance impact is not that important. One of the problems was that the API had to be changed. And since it was a security issue, we also had to change the API in the LTS version. So that's something that we don't usually do. So it was a common effort with the maintainer. So, for example, I would like to thank Luca, who spent some time to organize all this. And now, I don't remember exactly in which version it is, but if you use the host user and you don't trust your guest, we would really suggest to update your user backend. And one thing that we discussed, but that we didn't make progress yet, is that we need to in the DPDK community to establish a process to handle CVEs. Okay. Okay, good. And Red Hat security team proposed their help to set up one if we need some advices. Jayu, you from Intel worked about live migration between Vhost kernel backend and Vhost user to Vhost user backend. One problem is that until 1802, the Vhost user backend didn't support the same all the features that are supported by the Vhost net kernel backend. And so it would mean that if this feature were negotiated, when you would migrate from Vhost net to Vhost user, the migration would fail. So Jayu added the support for all these missing features. So now this is possible when you have a recent DPDK to migrate from the kernel to the user backend. But still, this is not enough because there is nothing to check today if the Vhost user backend is supporting this feature. So if it is an older one, the migration would still fail. So what we need would be to have a tool which would certainly go into QEMU to check the features before initiating any migration. And it would also work for migrating from different versions of user backends, not only from kernel to user.
Okay. Over the last year and a half, the Virtio community has been discussing and working on some features, some new developments that will eventually make it into the new version of the standard Virtio 1.1. And one of these features will be in-order processing. Support for DPDK is already upstream, also is Marvin Liu from Intel, I believe. And so what this is basically is a new feature bit was defined for this in Virtio, and what this means is that when device and driver negotiate this feature, they basically agree to process descriptors in a ring order. And what this gives us then is basically we have less accesses to the actual ring, which means we do batch notification. We can do batch notification. And apart from that, it will also allow for new implementations to have a simpler driver code and simpler device implementation. These performance numbers I pulled from the commit log from the cover letter. It's just one example, but it's quite a nice improvement. Another feature that went in upstream in the last year is support for Vhost data path acceleration. There was an entire talk about this at this conference last year, I believe. So basically what this allows us is to support hardware devices that are compatible with the Virtio ring format. And so we can, the hardware device can talk basically to the Virtio driver directly. This can allows us to offload the data paths to hardware while keeping the control paths in a usual way via the Vhost user protocol. There was also a driver upstream for this. It's also in DPDK. I don't remember which version, but it's in there. That's so for the features that were added last year. What we're planning to work on, it's not exclusive, but some things should be mentioned here. And one thing is also part of what will become Virtio 1.1, support for packed word queues. The Vhost part of this is also already upstream. The Virtio PMD driver part, we still hope to get it into 18.11. There were some versions of this patch set already sent out. Another one will follow very soon. What's the motivation for packed word queues? Actually, the motivation for or focus for Virtio 1.1 in general is making it easier to allow implementations in hardware, so to offload it to hardware. But not also for hardware, also for pure software implementations, we expect performance benefits by having a simpler ring layout. So right now, the Virtio layout looks like this. We have, I call this split Virtios for now. It consists basically of 5 parts. We have an available ring, a descriptor ring, a used ring, and then pointers pointing to the rings. And the way Virtio works basically is we have host and guests passing messages through shared memory, and this could possibly be on different CPUs, and by this causing a lot of cache synchronization. We need to, for every buffer we transfer from host to guest and vice versa, we have at least 5 accesses. And that's causing a lot of cache synchronization messages and so on. It's a lot of overhead, basically. So clearly the problem seems to be that the information that we need for this one request is spread over too many data structures. And what we want to do to resolve this is pack this information more tightly together. And what we've done is we put it into a single data structure. So what we have now basically is a single ring, a descriptor ring. And for the driver to write out an available descriptor that can be consumed by the host, it will write it into the ring. And similarly, if the device marks a descriptor as used, it will also write it into this position in the same ring. A descriptor consists of these few fields here, address, links, ID, and then we have flags in the descriptor ring. We have 2 flags, an available flag and a used flag, comparable to the available ring and used ring that we had before. So we basically have this one ring and this one descriptor data structure that contains all these data that we had before spread over multiple data structures. And it fits into a cache line. So to mark a descriptor as valid, what the driver does is just flip this available bit. And the host, when it marks a descriptor as used, it will flip the used bit. So the ring is 0 initialized, and in the first pass, basically what we do is, as I said, available descriptors will result in this available flag becoming 1, and also the device will also mark this used flag. And then once the ring has wrapped once, another thing comes into play. Both driver and device are expected to maintain a wrap counter. And that means in the second pass, once the ring has wrapped, we mark it basically the other way around. So still, the driver only always ever flips the available bit, and the device is flipping the used bit. And basically, this wrap counter allows us to detect newly made available descriptors after the ring has wrapped once. So that's just a short introduction to packed word queues. Something else that is more of an still needs to be worked on, but it is also will be part of Virtio 1.1. We will, for packed word queues, we will remove the requirement that rings have to be the size of the rings has to be a power of 2. And the reason for this is to improve cache utilization, so especially with large rings. Imagine that we have a ring with 1,000 1K entries, and that makes the ring a size of 16K bytes. Now, if we have a CPU that has an 8-way associative cache, we've already filled half of that. Now, if you imagine we have a networking device that has to receive and transmit queues, then that means basically all the data is pushed out of the cache. So the idea here is, and it's not my idea, came out of the community, it's microcircuits idea, but we'll benchmark it, is make the ring just a little bit smaller, not half of it, but say 786, 68 descriptors, and that will leave us for some space for other data in the cache. And with that, I hand back to Maxime.
Thanks. So a feature for which I posted the RFC last week or 2 weeks ago is post-copy live migration. So first, before talking about post-copy, I will explain what is the other way, which is pre-copy live migration. So when we decide to migrate a VM from a source to a destination, while the pages are being copied to the destination, the VM is still running on the source. And as you can imagine, some pages that are already copied will be dirtied, will be written by the source. So in this case, when it happens, these pages are tagged as dirty, and then later we copy them again. At some point, the remaining pages are dirtied too fast to be copied. And so what happens is that we halt the source, copy the remaining pages, and once done, we start again, we resume on the destination. With post-copy, it's a bit different. What happens is that the source, when we trigger the migration, just copy a minimal set of pages that matches the VM execution state. And as soon as it is copied, the VM is halted on source and resumed in the destination. So the destination will try to access pages that are not copied yet. And when it happens, we get a page fault, and the destination VM gets paused and requests the missing page to the source. And when the page is received, the source map it and resume the VM. So QEMU supports post-copy live migration, and it relies on user fault FD to manage page faults. So what happens is that QEMU registers all the guest memory region to user fault FD, and one thread in QEMU is dedicated to handle the page fault. And when a page fault happens, the thread gets the address, request to the source QEMU the missing pages, remap it into the destination, and notify user fault that the page is now ready, and the VM is resumed. What's missing today is support for Vhost user backend. So the problem is that with Vhost user, we have to handle page faults coming from another process. But with user fault FD, it is possible to handle page fault of another process because we can pass because the backend can register to user fault FD and pass the file descriptor that corresponds to the memory region to QEMU via the ancillary data. So I posted the RFC last week with some early benchmark. So I don't have a setup today to run real use cases. But what we see is that in my benchmarks is that it reduces the migration total time not the downtime, the total time, simply because we don't copy the same page multiple times. One open issue is that user-fault-fd doesn't support, requires the application not to call mlock all. The page, because the page does not have to be populated before it gets registered to user-fault-fd. And if it happens, the migration will break. And that's a problem, but it's not really a problem with QEMU, because QEMU is its own process, so it can just not call mlock all. But in the case of Vhost user, it's a bit different, because it's a library. So the library cannot control whether the application can or not call mlock all. For now, we don't have much ideas on how to solve this. Maybe the solution will be, for now at least, to disable post-copy by default, so that the application, maybe via a new API or via a new parameter for the Vhost PMD, enables it, so that the application enables it only if it knows it will never call mlock all. So that's an open issue. If you have some ideas, it's welcome. And I couldn't run much tests because we have some instabilities. Some are in the kernel, some are in QEMU. So we are fixing these bugs, and maybe after we could do proper benchmarking. Another topic that was raised by Darius from Intel SPDK was that currently our Vhost library is not really compliant with the Virtio specification. And this is related to the queue initialization. So our implementation today complies with the network backend, but with for SPDK, for the SCSI and block backend, it does not work. They have to implement today some workarounds. So Darius proposed to have a new version of the Vhost library, and some people disagree. So that's a topic that is important that we need to address. But maybe we could continue with the current library and current API and just evolve it from version to version. So that's a topic that is being discussed today.
So in the past year, we saw new maintainers and quite some interesting topics with VDPA, IMMU, and packed Virtios. And for the next year, we just talked about what was coming there. And on top of that, I think we'll see some more of the Virtio 1.1 features and some more things that will aim for improving or making it easier to support hardware offload. Another thing we wanted to mention is that we have a monthly meeting where we discuss all things Virtio, DPDK or not. And everybody is welcome to join if you are interested in a feature in Virtio, or if you work on hardware offload and you have questions, or if you just want to work on something, you're very welcome to join. Send me an email, and we will add you to the meeting. Another thing we wanted to mention, there will be buffs today. We will have a Virtio buff, so please join us if you want to use the chance to discuss things with us. Yeah, and that's the end of our talk. I believe, are there any questions? There's one in the back.
So this is Edwin from Intel. We have access in dirty bits to hardware accelerate. So we keep track of dirty page marking, right? So this could greatly accelerate your migration. So we ran some benchmarking in our labs, and we saw with dirty page tracking, we can migrate those dirty pages a lot sooner than when you VMX it on those dirty pages. So that's something you probably want to look into. And then the other thing is we've used compression to basically, if you have huge pages, right, so 2 meg pages, you might not get the gains, but if you're migrating gig pages, you could consider, or even 2 meg you benefit as well, but much bigger benefits when you migrate gig pages and compress them prior to migration.
Okay.
And then on your, what was the queue configuration on your benchmark that you presented earlier on? Yeah. So you mentioned that you had from 1 queue to 4 queue, you went to 26 million packets per second or something like that.
Oh, for the in-order processing?
Yes.
I don't know. We'd have to ask the patch author. I don't know if it's here. If not, we have to clarify offline. He's also from Intel. So.
Yeah, from the Intel side.
Hello. I have a question regarding kernel and QEMU support for in-order feature and packed rings. Actually, I read some mail lists, and I see that packed rings work. It's kind of freezed for kernel. It's considered non-profitable for kernel. And after that, QEMU porting, QEMU implementation for this feature also stuck. There's no updates, no mails, no patches. Actually, I wanted to try myself in-order feature in QEMU, and I had to implement it. Maybe you saw my patches, which we had discussed with Michael. There's some issues. So I wanted to ask, is there some progress? Is someone works on QEMU part, kernel part? Because otherwise it can be used in production with virtual machines. It's only for virtual user maybe.
Yeah, so of course the plan is to get it into both QEMU and kernel for Vhost. It's correct that Vhost patches are currently stuck because we would like to prove a performance benefit with the Virtio PMD. And that's what I'm currently working on, getting this benchmark and getting the numbers to prove that we will have a benefit there. And that will mean that we can also get the Vhost patches into the kernel. And what I know of the QEMU implementation, that it's also well underway, and it just basically also depends on the investigation for the benefit in Vhost.
Yeah, actually, yes. I'm asking because there was no any updates for a few months for packet rings implementation for QEMU. And,
yeah, so our colleague Wei is still working on that, and there will be new versions very soon.
Okay. Jan Scheurich, Ericsson. We discussed a bit about the possibility to negotiate the number of Virtio queue pairs between QEMU and the backend. Has there been any work on this,
Yes.
or is it on hold?
Yeah, so I posted some patches for QEMU.
Okay.
And the feedback was not very good, so I need to come up with a new solution for this.
Okay.
So yes, the idea was, so that's what I proposed you was to today we are not flexible enough, and the problem is that if you declare less queue in Vhost backend, then more queue in the Vhost backend than the one declared into QEMU, it will fail to initialize. Mm-hmm. No, that's opposite. And so my proposal was to take the minimum of the two values, but some people remember who was not really happy with the solution, so I need to rework on it.
Okay,
I don't
thank
forget you.
Okay, thank you, Harry. I was really trying to play the throw and catch, but and well, thank you, Maxime and Jens, for the great summary. I just have one quick question on the lab migration part, the post copy. Probably already mentioned this, but or maybe I missed it. But I just want to know what's the expected downtime and packet loss when we use the new post copy lab migration.
Yeah. So for the downtime, I think it will be almost the same. What will decrease will be the total migration time. And that's what I see with my first benchmark, but it's not very stable, and I'm migrating on the same machine, so it's not representing a real use case. But from the result I get, the downtime is the same between pre-copy live migration and post-copy live migration. But for the total migration time, if I flood the Virtio.net device, the total migration time is divided by nearly 10. But
okay, and another part is, so previously when the traffic is heavy, the migration might fail, right? Just failed, and in this new method, so it won't fail in that case?
yes, so normally yes, that's the goal. It's so when you have user backend and you do pre-copy live migration, you can pause the VM, but the user backend can still be accessing the pages, and so it could make the migration to fail. Because it never converges between the source and the destination. And with post copies, the advantage is that you will the shared memory pages will be only copied once. You will not have to copy them again and again because it always gets dirty. So yes, normally there could be an improvement with this with post copy for this.
Thanks.
Hi, I'm from Intel. I have one question actually for the DMA device, in-flight request. For example, in the source, source end, you have source end, destination end for your live migration, right? In the source end, the device may have some in-flight request. For example, when you start live migration, your source may hot virtual machine, no problem, but the device just continue, DMA back the new content. But then in your destination side, right, you may not hold the latest version at all for that memory as you expected. Do you have any solution to handle that? Because the in-flight request means when you hot your source destination, you won't send a new request to hardware, right? But hardware still have some kind of request wasn't complete. You just keep sending back DMA,
But I don't see the difference between post-copy and pre-copy for this. You could have the same kind of issue, no?
Because I think in your post-copy, because you send out, you transfer the minimum memory set as you thought, right? So then you go into your destination side. You thought you hold it. In destination side, think he hold this memory already. But that memory content actually is outdated because of in-flight request in source side.
Yeah, but the port is stopped on the source side.
Because device not really can stop, because it's in-flight, right? You have some requests are still in the middle of processing, Okay, maybe we can discuss offline. It's a little complicated. Okay.
Quick question. What kind of real application do you plan to use to test the live migration?
So today, the first reason why we we had support for post-copy live migration to the user backend is to not prevent post-copy live migration. Because today, even if you have a user backend and you want to do post-copy live migration, it's not possible. So you block all the VM for this. I mean, you cannot do the migration.
With that, thank you.